Hey everyone, welcome to Slice of Life Coding by Jamie Dawson Codes, a video series where I tackle questions you can find on LeetCode 150 and beyond. In this video, we're going to be going over a very common medium-level LeetCode question called Koko Eating Bananas. So before we even discuss algorithms, let's go ahead and make sure we actually understand what this question is asking us to do. So, Koko loves to eat bananas. There are n piles of bananas. The ith pile has piles I bananas. The guards have gone and will come back in h hours. Koko can decide her bananas per hour eating speed of k. Each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Koko likes to eat slowly but still wants to finish eating all the bananas before the guards return. Return the minimum integer k such that she can eat all the bananas within h hours. So if you don't understand exactly what that is saying, let's go ahead and use example number 1 to kind of wrap our heads around what this is asking us to do. So to understand the problem, let's actually go through the example. So in the piles array, every single spot has a certain amount of bananas. So you'll see here we have 3 bananas, 6 bananas, 7 bananas, and 11 bananas. And the hours is set to 8. So to kind of start off and wrap our head around this, let's ask ourselves, how many bananas could we get through and how many hours would it take in total if we were to eat 3 bananas an hour? So in the first spot, it would actually take us just 1 hour to get through 3 bananas if we're allowed to eat 3 bananas an hour. Now in the second spot here, it would take us 2 hours to get through 6 bananas because 3 times 2 is 6. Now in this spot right here, you'll see there's only 1 extra banana, but we still need that whole extra hour just to eat that 1 extra banana that's past 6. So it wouldn't really matter if this right here was 8 or 9. You would still need that whole extra hour, which totals up to 3 hours, to get that 1 last banana that's in that spot right here. And the same goes for this situation right here with 11. So yeah, 3 times 3 is 9. But you still need that 4th hour to get through the last 2 bananas. So even if this was 10, 11, or 12, you would still, whichever one you pick, it would still need to have that 4th extra hour to handle that amount of bananas. And as a result, you add all the hours together, and then you would get 10 hours. Now, that is not 8, so you have to ask yourself, should I be eating less bananas or more bananas? So if you were to check maybe less bananas, you would see in this situation with 2 bananas an hour, it would take me 2 hours to get through 3 bananas, 3 to get through 6, 4 to get through 7, and 6 to get through 11. But that would actually get us further away from our goal and set it to 15. So now I think, all right, what would happen if I ate more bananas an hour? So instead of 3, I eat 4 bananas an hour. Well, in this situation, it would take me 1 hour to get through 3 bananas, 2 hours to get through 6, 2 hours to get through 7, and then 3 hours to get through 11. And as a result, this would give us the number 8, which would tell us, I think, the best option to get through all these bananas to reach our goal of 8 would be 4 bananas an hour. So now that we know what the question is actually asking us to do, let's go ahead and discuss the algorithm that we use to solve it. So the algorithm that we're going to be using to solve it involves binary search. Now, I have a much larger video that kind of goes into a deep dive of what this algorithm is, but if you want to watch that, I'll link it in the description. But for this video, I'll just give a brief description of basically what binary search is. So to understand binary search, the algorithm, we're going to use this example where we're going to take a sorted array, and we need to find the number 7 in the sorted array. And what you're going to be doing in your sorted array is that you're going to be creating 3 variables. One that starts at the beginning, one that starts at the end, and then one that finds the middle. And the middle is found by just taking the left and right pointer and adding them, and then dividing that number by 2. So in this example, 0 plus 5 divided by 2 is equal to 2. And so what you're going to do with those pointers is you're going to ask, one of 3 things is going to happen. Either the middle pointer is going to be pointing to the number that we're looking at, and then you'll just return that middle pointer. Or the variable m is going to be less than the number we're looking for. And if that's the case, we would take the L pointer and point it and move it like one space to the right of m, or it's the opposite where the middle pointer is actually bigger than the number we're looking for. In that case, we would take the right pointer and move it to the left of the middle pointer. And so we're basically just going to be moving left and right over and over again to the sides of m until we get to the till we either find the number that we're looking for. So in this example, we see that m is equal to 5, so 5 is less than 7. So we're going to take the left pointer and move it 1 to the right. So now that the left pointer was moved to the right, r is still there. We went ahead and added 3 plus 5. So 3 plus 5 divided by 2 was 4. And as a result, the middle pointer got put to here. And then we see all right, is the middle pointer equal to 7? No, it's equal to 9. And that means that it's bigger than 7. So as a result, we need to take the right pointer and move it one space to the left of middle. So we ended up doing that. And what ended up happening is that here we said, all right, left pointer plus right pointer divided by 2. So 3 plus 3 divided by 0 is 3. And then, all right, so now that we know that, we can set the middle to 3. And we did that. So middle pointer is now pointing to 7. So that means we can return the middle pointer. So that's basically how binary search works, is that you can kind of think of it like taking a phone book and splicing it in half over and over again to find the name. For example, if I was looking for a last name that started with the letter E, and I opened up in the middle of the phone book, and I started somewhere with maybe the letter M, I was like, okay, well, M is bigger than E, so let's take this half, slice it, and just keep doing that till I find the name that I'm looking for. And that actually kind of goes into something really important here with binary search and why it's so popular. It's because it has a time complexity of O of log n. So unlike O of n, where you would be scanning the entire array to find the number you're looking for, log n is basically means that you're taking the array and you just keep slicing it over and over again in halves until you find what you're looking for. So I would actually say anytime you see a LeetCode question telling you, hey, try to opt in for log n, it's a pretty good indicator that you should be using binary search to solve this problem. Now at this point, you're probably thinking, all right, well, binary search seems like a great algorithm to use, but I don't exactly know how I would use that for this problem. Because yeah, in this example, Pyle's array is sorted from smallest to largest, but that's not always the case. And I think that's actually the reason a lot of people don't think to use binary search for this problem. So what we're going to be doing is that instead of actually creating an array of sorted numbers, we're going to just be creating 3 variables, and those 3 variables will kind of represent a certain length of numbers that we need to actually solve this problem and use binary search on those numbers. So in this example, I first set the left pointer to 1, and I do that instead of setting it to 0 because it doesn't make sense to check how many bananas could I eat per hour if I'm allowed to eat 0 bananas. Doesn't make sense, so we just set it to 1. And then the right variable is set to 11 because 11 is the biggest number you can find in the array. And so that's how you get this length of numbers that you can kind of play around with. And like before, the middle pointer represents left plus right divided by 2. And the total hours variable, this will be created by basically looping through the entire list, checking the Pyle's amount divided by m, whatever that may be, going through here and storing the collected amount of hours you get by scanning through this. And we're going to keep doing that while the left pointer is less than or equal then to the right pointer. Unlike regular binary search where you would return the middle pointer, you're only going to be returning the left pointer. And as you see this algorithm go step by step, you're going to see why. So starting off, we got left is 1, right is 11. And so 12 divided by 2, well, that's 6. So I can eat 6 bananas an hour. So what I'm going to do is I'm going to say, okay, it takes 1 hour. If I'm allowed 6 bananas an hour, well, it would take me 1 hour to get through 3. It'd take me 1 hour to get through 6, 2 hours to get through 7, and then 2 hours to get through 11. So that gives us 6 total hours. Now, 6 is less than or equal to 8, so we can try slower. So what I'm going to do is I'm going to set the right variable to be 1 less than the middle variable. So at this point, now we got 1 plus 5. So that would equal divided by 2, and that would equal 3. So funny enough, we've already kind of like gone through this, so I'll make it really quick. Yeah, so 3 bananas an hour for 3, that's 1. 3 bananas for 3 bananas an hour with 6 bananas, that's 2. 3 bananas with 7, that is 3. And then if I could eat 3 bananas an hour and there's 11, that takes 4 hours, so that's 10 hours. So that gives us 10, and 10 is greater than 8, so that's too slow. So we need to try faster. So in that case, we're going to set the left pointer to be 1 past the middle pointer. So now that we've done that, we have left plus right. So 4 plus 5 divided by 2, and that gives us 4. So I'm allowed to eat 4 bananas an hour. So 4 bananas an hour, if there's 3, that takes 1 hour. 4 bananas if there's an hour and there's 6, it gives 2. 4 bananas an hour and there's 7 bananas, that's 2 hours again. And then 4 bananas an hour and there's 11 bananas, that takes me 3 hours. So in total, that sets me to 8 hours. Now in this example, it says, all right, so 8 is less than or equal to 8, so we need to try slower. And so we're going to set the right pointer to be 1 to the left of middle. And so what happens is that that pointer will be set here. So left will no longer be less than or equal to right. And as a result, we would stop the loop, and then we would return whatever the left pointer is pointing to, which would be 4. So I've broken this problem down into 4 sections. First is creating the variables for the binary search and the variable I need to track the total, which I'm going to call left, right, k. The next step is to create a binary search loop. Now, inside this binary search loop, I'm going to be calling a function that I'll need to gather the total. So I'll create that function out of here. And then lastly, I'm going to be returning the left variable. All right, so to start, I need to get the first number. So that will be 1. Now, for the last number, my binary search needs to be the largest out of piles. So I'll do let.right equals math.max. And I will just use a spread operator on piles to find that. And lastly, I'll just set k for now, and I'll use that to track the total. So to start on a binary search loop, I just need to make a while loop that is left is less than or equal to right. I need to find the middle, so I will set the middle variable to math.floor, and I'm going to do right plus left divided by 2. Now this k variable we created, I'm going to use this to store the total amount of hours it takes to eat all the bananas, and that will be pulled from the function that I'm going to be creating up here. And I'm going to call that function find total, and I'll pass in piles and middle. But before I create that function, I'm going to go ahead and just wrap up this loop. So while considering h, I will do if k is less than or equal to h, then I'll set right equal to middle minus 1. Else, I will set left equal to middle plus 1. So now that the loop is done, let's go ahead and create our find total function. So to do that, I'm going to come up here. I'm going to do const find total. Now piles is a numbers array, and middle is a number, and we are going to be returning a number. So I'm going to make a variable in here called total, and I'll set that to 0. And from here, I'm just going to do a basic loop to gather up all the numbers together. So to do that, do for let I equals 0, I is less than piles.length, I plus plus. Now total is going to be equal to, or plus equals to math.ceil. Piles, the current number in piles, divided by middle. You can do that. and then we just return total. And now our last step is just to return left. Let's test this out to see if it works. And as you can see, our code passes. So lastly, I want to make sure that you can pass this interview if you get this question. So to do that, you're going to need to know the space and time complexity of this problem. So space is super straightforward. We're just creating number variables. We're not creating anything the size of piles, nor are we really doing any kind of recursion. So we can just call that O of 1. Next, we got time complexity. So time complexity is O of n log max pile. And what that means is when I say that is you would want to say, I scan the entire list of piles over and over in the find total function, but only log pile times. So in the find total function, you're passing in piles and you are scanning the entire array every single time when you pass in here, but you're only doing it the amount of times that binary search will allow you. And the value of a max pile, that just represents like whatever this number happens to be. So yeah, you are scanning the entire array over and over, but you're doing it within a binary search amount. All right, that's it for Koko Eating Bananas. I'm experimenting with a different style of videos here for LeetCode training, so if you got thoughts or feedback, I'd love to hear it. I'm planning on uploading lots more LeetCode videos in this format, so I hope this helped, even just a little bit. And I'll catch you in the next one. Take it easy.